Good afternoon. Today we are going to be speaking about question 16 in the Stawa Physics 3AB book. So question 16 asks, a stunned woman is attempting to jump her car across a pair of ramps that are 38 meters apart. To successfully complete the jump, she must drive her car at a minimum speed constant up the ramp. If she leaves the ramp with an initial speed of 108 kilometers per hour, calculate in meters per second the vertical and horizontal components of her velocity. So firstly, to make it easier, let's convert the 108 kilometers per hour into, let's get rid of that, meters per second. So that is 108 divided by 3.6, which is 30 meters per second. So, always, to start us off, we draw a vector triangle. So that is 30 meters per second, as we just worked out. And the angle that she takes off at is 15 degrees, so that's 15. Now, to work out, these are our horizontal and vertical components. For the vertical, it is 30 sine 15, as it is opposite over adjacent. And for the horizontal, it is 30 cos 15, as it is adjacent over hypotenuse. Question 2, or question B. Will there be a point during the flight of the car where the stunned woman and her car experience zero acceleration? If so, where? Well, firstly, we know that in the horizontal plane, the speed or the horizontal velocity is always constant, as there is no force acting on it. However, in the vertical plane, or the vertical component, there is always gravity acting on it, or negative 9.8 meters per second acting down on it. Therefore, the answer to that question is no, as gravity will always be acting down on the car. Question C. What will be the velocity of the car at its highest point? Okay, so at its highest point, if we draw a parabola, the highest point will be here. Now, at its highest point, it does not go up and it does not go down. Therefore, its vertical component, so the vertical velocity, would equal 0 meters per second. However, the horizontal velocity remains constant and does not change. Therefore, the speed at which she reaches at the highest point would be 29 meters per second, as that's what we evaluated 30 cos 15 to be, to the right, as she's moving from left to right. Question D. At what point A, B, C, D, or E in her journey will she have the greatest speed, and why? Well, assuming that her foot is pressed fully down on the pedal, the greatest speed will be A. But if you forget about air resistance, it could also be B, as if air resistance occurred, it would fall short. So therefore, that's why it would be A or B, or E, sorry. Oh, Jesus Christ. This is a nightmare. I hate you, Miss Edmonds. Question E. Now this is a tough question, but I had no problem. So, firstly, at what minimum speed must she leave the ramp so as to make it to the other side? Well, firstly, let's draw our vector diagram. Now we know that angle is 15 degrees because that hasn't changed. But we don't know the velocity, which is what we're trying to find out. So we'll call that v. But since we don't know that, we can't work these out in terms of actual velocity. So we use v instead. So for the vertical, the vertical component would be v sine 15, and for the horizontal, v cos 15. Now, once we have that, we need to work out an expression for t, as we can therefore know how long it takes to travel. So, the expression for t is s equals vt, v being the horizontal component, as there's no acceleration involved, as in the horizontal component the speed is the same. S would equal 38 meters, as that is given to us. V is the horizontal component, which is v cos 15, and t is what we're trying to find out. So an expression for t is t equals 38 over v cos 15. We can simplify that to make it easier for us. So 38 divided by cos 15 is 39.3, and then it's just over v. So now we have t. Now we go into our second equation to find the actual thing we're trying to find out, which is her minimum initial velocity. So we use s equals ut plus a half a t squared. S is 0, as she comes back to the same height she left, and this is for the vertical component, and therefore her vertical displacement is 0. So we use the vertical component, which is v sine 15, times t, which we worked out to be 39.3 over v, plus negative 9.8, which is gravity, times 39.3 over v squared. So we can evaluate that. The 0 equals, those v's cancel, so then it's just sine 15 times 39.3, and that a plus and a minus, it just becomes minus 0.5, which I forgot to put in, so that's 4.9, because that's half of 9.8, times by 39.3 squared, which is 1544.5 over v squared. Now we can move that to the other side, so that becomes sine 15 times 39.3 is 10.17. So as we move it to the other side, it becomes negative, equals negative 4.9 times 1544.5, so that is 5, negative 67568.05 over v squared. So to v squared, we simply move v squared by itself and bring the negative 10.17 down. So v squared equals negative 7568. I'm videoing. Shh. Over negative 10.17, which equals 744.2 2, and then we square root that to equal 27.3 meters per second. Thank you for listening. I hope you have enjoyed.